My name is Jeff Essen. I'm a naturopathic doctor. What does that mean is the usual follow-up question to that, because most people have never really heard of that. But that means that in naturopathic school, I didn't study pharmacology or pathology. I didn't want to understand chemistry or diseases. What we study in naturopathic school is each part and its contribution to the whole, each part and its interlinking to all of the other systems of the body, and the body's balances and imbalances and how they interact with one another. So if I have something wrong over here, how is that going to affect this? If I have something wrong here, that's a symptom. But the symptom may not be the source of the problem. In fact, seldom is. I always give the example of constipation. Virtually no one with constipation has a large intestine problem. So in that case, we look, where did the constipation source from? Well, that's usually the GI belt. We got stomach, gallbladder, pancreas. The problem is up here, but the symptom is constipation. The allopathic medical model would treat the colon and ignore this up here entirely. So in that case, what a naturopath does is thinks opposite to what your MD does. I literally think backwards. I think in opposites, and that's how we had to train in naturopathic schools, to look at this and say, if indeed you have a symptom, that's your body trying to achieve balance given the situation that exists and given the tools that it has. So if you have a symptom and then you suppress that symptom, what are you doing? You're shutting down the healing process. It kind of doesn't make sense. So in naturopathic school, again, we think very differently, we think opposite. We try to go from the standpoint of, if we simply provide a situation where the body has the tools, resources, nutrition to heal itself, we just do that and let that go on its own. So in any of the things that I'm going to say tonight, all that comes from the idea of not, you have this symptom, here, take this. You can get that out of a book. A book could be, and in fact, for most of what your medical doctors do in your typical clinic scenario, they could easily be replaced by a computer. Just a database of information is most of what they are. You come in, you say, I have this symptom, I have that symptom, I have that symptom, that equals this set of drugs, go take those. A computer could do that very easily. Now, a computer can't do a physical exam, can't, if you break your arm, you can't set it, put a cast on it. Physicians are needed for that kind of work, but most of what's done in the prescription model is that way. And again, the naturopath would just go crazy in that environment. We can't just say, take this for this. That doesn't work that way. Okay? So in that circumstance, we're going to talk about hormones tonight. And as far as hormones go, they're very complex, very interactive, extremely sensitive systems that have multiple different reasons why one symptom could be occurring. Hot flashes is a common symptom. It can be from any one of 4 different sources. Which of the 4 do you happen to have hot flash version?
What all 4?
Well, and it can be that.
I feel like
yes. If it's, and so in that circumstance, everything we're going to talk to you tonight is about understanding not only the parts, but how the parts work together. Okay? So we're going to dive in. Most people don't even really know what a hormone is. We use this generic term hormones. What are they really? They are little messengers. It comes from the Greek impetus, or the idea of something to create motion, to create a stimulus. And that's exactly what they do. The hormones interact with your cells. They bring a message to the cell and say, cell, do this, or don't do that. Okay? So a hormone is a class of regulatory biochemicals produced in multicellular organisms like glands, transported via the circulatory system to a distant target organ to coordinate its physiology and behavior. To coordinate is the big phrase there. Hormones help your body act appropriately given the situation. So in a circumstance where you're cold, you have hormones that increase your body's core temperature to keep your vital organs safe and warm. That's just a sample of what a hormonal function might be. So all of those messengers are running all around your body all the time. The cool thing about them is that they are virtually not there. When we're talking about the molecular weight, when we're talking about the actual amount of chemical substance, hormones are very, very small, light, almost not there. they're more energetic than they are chemical. That's the beauty of them, because a small amount of hormone can do a massive amount of messaging. Now, it's also a very complex process here. Complex, what I mean by complex is, you don't just have a gland and it produces stuff and then it goes out to the cells. That is what allopaths think sometimes. I've seen them actually be very ignorant about this. There's a very complex process that has to happen for a hormonal process to be appropriate and used in your body. First of all, you got the cell. The cell is the ultimate destination of every hormone. Every hormone's mission is to go to a cell to deliver a message. The cell is going to say, hey, we need some more stuff down here. We need more hormones. That's going to send a message to the hypothalamus. Anybody know where the hypothalamus is? It's in the brain stem, yes. It's kind of right behind your hard palate. It's in that part of the brain that sort of stems down into your nervous system. It's where your pituitary gland happens to be located. So the messages are sent to the hypothalamus. The hypothalamus says, oh, we're getting all these messages from down there. We need to react to something. Hey, pituitary gland, make this hormone that's going to go stimulate that gland. That gland, ovaries, testicles, adrenals, pancreas, thyroid, thymus, are going to then produce what they're stimulated to produce, but then does it go to the cell then? In most cases, not. In most cases, it's going to go to the liver and gallbladder to lump in onto a molecule of cholesterol. Cholesterol, the evil demon, bad thing. And I could go all night about that, so don't get me started. Cholesterol becomes the bus upon which the hormones ride around the body to be delivered finally to the cell. This is not a simple process. Just to orient you, I'm going to tell you about how the thyroid system might be an example of how the thyroid works. So again, you got your cells. Cells say, we need more thyroid down here, so they're going to produce something called thyrotropic releasing factor, otherwise known as TRF. That's a little protein. Protein travels in the bloodstream to the brain, where it enters the hypothalamus. The hypothalamus says, oh, you guys need thyroid down there? Okay, let me use some modulatory neuropeptides to stimulate the pituitary. The pituitary is going to then make TSH. Can anybody tell me what TSH is? Thyroid stimulating hormone, which happens to be the only thing that most medical doctors will rely upon for your thyroid doses, or diagnosis, by the way. So then the TSH hits the thyroid gland itself. Thyroid gland right here behind your voice box, shaped like a butterfly, largest gland you have, by the way, produces then T4. 97% of the output is T4. T3 is only 3% of its production. Now, in your body, what your cells really want is T3. Why would it produce 97% T4? T4 is largely unusable by your cells. It doesn't really do much in the body. It does that so we can regulate things, but ultimately, the T4 gets routed to the liver and gallbladder, where the liver conjugates it or changes the molecular structure into T3. Then that T3 is lumped onto a molecule of cholesterol. The cholesterol is secreted through the bile pathway, through the gallbladder, and then goes out into the system. Okay, I can tell you right now, I have had at least 24 patients. Thyroid symptoms up and down. They go get their TSH measured. No, your TSH is normal, which I'll show you this in a little bit, that it wasn't normal. And then they still just feel terrible. You know, what are symptoms of hypothyroidism? Weight gain for no good reason. In other words, you can be on a diet, you can be on an exercise, and you're still gaining weight. You're tired, you're fatigued, you just cannot generate energy. Headaches when you wake up in the morning, can't get going for the day, your metabolism is poor. Blood sugar can be a problem for you. Hair starts to fall out, so in the brush, on the sink, in the shower, lots of hair falling out, even though you're not really going bald. You're not getting thinning hair, it's just lots of hair falling out. Real troubles maintaining core body temperature, so when it's hot outside, you're in a sweater. When it's cold outside, you're in a sweater and a blanket and thermals. Okay, you cannot control your body temperature very well. That's all hypothyroidism. And so that's every symptom on the list, but their TSH is normal, even though it wasn't. The problem was in their liver and gallbladder. Give them a bunch of liver remedies, pop open their bile pathway, then start secreting all the T3 into the system, and poof, they're normal. Okay? So the problem with the allopathic model is You don't have enough thyroid in your system. You feel bad, here, take more.
Yeah.
Okay. This is a system that irritates the heck out of me because of its ignorance as to how the body works. Here's another problem. When you want to go get your hormones measured, how do they get measured? You're going for a blood test, right? There's a problem. There's a few problems with blood tests. I'm going to go over them. First of all, there's something called the laboratory normal. The laboratory normal is the range of low to high. If you're in that range, you are normal. If you're below that range, you're low. Above that range, you're high. How are those normals established is one significant question. What ends up happening is this, okay? A blood lab is required for every 1,000 patients to run a calculation of all the numbers for all the stuff, and they say, well, here was the lowest one we measured of those 1,000, here's the highest one we measured of those 1,000, and they have a bell curve average, just like that, and then they say, okay, well, we're gonna run the cutoff here and here, and this is now normal. Who did they just measure? If somebody was going in for a blood test, what do you presume about them? They're sick.
Yeah.
So you just established your normal range by the average of a bunch of sick people. Okay? And this isn't just with hormones. This is everything. This is things like anemia and all the CDC stuff, immune stuff. So in that circumstance, just the very model of a bell curve average is ridiculous. And the numbers of range will vary from region to region. You'll see different scores out east, out west, here in the Midwest, southern, all different based on all kinds of environmental and common dietary patterns in that area. Now, the laboratory normal listed here, let's say for TSH, for example, is 0.45 to 5. Now, somebody a long time ago, Dr. Harry Eidner, figured out that this just wasn't right because people still had symptoms, people still had problems, and you could actually go biopsy tissue and say, no, that's not accurate. So they did a very, very long, extensive program in Michigan, and it actually took over 2,000 people for over 10 years. And they did what's called a blood biopsy, and they really looked at what is the tissue saturation, what is the actual presence, what's optimum normal was what they were after. What is the normal outside of the bell curve average thing? Let's talk about what it means for you to be dynamically and vitally healthy. What are the real optimum normals for it? So in TSH, 0.45 to 5 now becomes at a functional normal, 1.8 to 3. Now, on a 5-point scale, with a 2-point difference on the high end of the deal, what percentage difference is that? That's a 40% difference in normal. You could be 39% below normal and still be considered normal. So you can be almost 40% sick and still be, well, there's nothing wrong with you. Okay? And this is just common throughout the whole paradigm of blood testing. And you see T4 here. You can have as low as 4.5 in their group. You have to have a minimum of 6 T4 to even approach normal with functional norms. And so when I do blood evaluations on people and I look at their blood tests or run blood tests on them, I look at it with functional normals rather than what the lab says. And for every one problem the lab finds, I'll find at least 6 or 7 problems that are outside normal in optimum numbers. Find anemia all the time. I mean, anemia is rampant in our society. You can't believe how many people are anemic, which is a gigantic problem I won't get into. Okay, now additionally, the very model of a blood test is also suspect to inaccuracy because, this little note down here, serum versus free fraction. You have what's known as globulin-bound hormones. So let's go back. They take your blood out of your arm, they put it into little vials. They take those vials, they put them in a little machine called a centrifuge, and they spin them around. What does that do? It separates it. Now you got the clear plasma on the bottom, and then you got your free fraction with the red blood cells on top. Here's the kicker. When you're measuring hormones via the normal lab system, they're measuring the serum, which has globulin-bound hormones. Where's the problem with that, Jeff? Well, here's the problem. Globulins are big sticky proteins. They're produced in the liver, they go out into the system, and this is to gather up used old hormones that are no longer electrically active, bind them and excrete them, usually through the urine. So in that circumstance, by measuring the serum and the globulin-bound hormones, it's equivalent to sticking a sensor up your tailpipe to find out how much gas you have in the tank. It is a related system, but it isn't the same thing, is it? It cannot be accurate. The only way that you can get an accurate hormone count by a blood test is to do what's called a free fraction test, where they measure whole blood rather than just the serum. And you'll never get a doctor to write the prescription for you. It's extremely expensive. Okay? So your problem is that you have an inaccurate testing modality and normals that are off to begin with. So your ability to even measure what's off to try to respond to your hormonal symptoms is suspect from the very start. Okay? Now let me describe how hormones work in your body. This is a simplified model, but here's the idea. Here is your membrane of any cell in your body. It's called a bilipid barrier. You've got a fatty cell here with one end that's water attracted here, fat attracted here, fat attracted here, water attracted here. So the fat causes those things to stick together, and then the water attracted thing called lipophilic wants to be by the blood out here and the plasma or the cytoplasm in here. So in that circumstance, you have a fatty acid membrane to every cell in your body. Fatty acids. Now, embedded in there are these proteins that are what you call receptor sites. So when something comes floating along in the bloodstream and says, oh, I'm attracted to that cell, it's going to go into one of those receptor sites and say, hi, how you doing? Okay? So when it goes in there and it attracts and it attaches to one of these, then the protein fluxes. And then you have these messenger proteins that go down these little tiny filaments and go down to the protein sleeve surrounding the DNA. And it's kind of like when you hit a set of keys on a keyboard and you go, boom, and you get this chord. Each one of those keys is going to then start to activate an AT or CG